Question number 14. It says which of the following statements or statement is or are correct about the spectrum of hydrogen atom. So there are four options. We need to read them and then we need to decide which one is correct or not. So option A says the ratio of longest wavelength to the shortest wavelength in the Balmer series is this. We need to check that. Now let's see one by one options. So Balmer series is talking about the Balmer series, and we know for Balmer series wavelength will be decided by the energy levels, or we can say these n equal to 2, and then higher n's starting from 3, 4, 5 and onwards. So if you want to get the maximum wavelength, that means longest wavelength. So longest wavelength is going to be from n equal to 3 to n equal to 2. So it's going to like r 1 upon 2 square minus 1 upon 3 square. Now these numbers we can simplify. It's like basically 1 by 4 minus 1 by 9. That turn out to be 5r by 36. Similarly, we can find out the shortest wavelength, that means lambda minimum, and that will be the one which will come from infinity to n equal to 2 level. So that will become r by 4, basically 1 upon lambda minimum. So from here the ratio of max by min we can find out. That means out of this, if we divide this, so it will be lambda max upon lambda min. So it will be r by 4 divided by 5r by 36. R will get cancelled out and this 36 will go upside, so it's going to be 9 by 5 ultimately. So the ratio of maximum or longest to shortest wavelength in Balmer series comes out to be 9 by 5. Option A, or the statement of A option, is exactly the same. Hence A is the correct response. Now option number B we talk about. So it says there is an overlap between wavelength ranges of Balmer and Paschen series. Now you can think of about Paschen series. In this, the electrons that are coming down is basically up to the level n equal to 3. So for Paschen series we can find the maximum wavelength, and that will be from 4 to 3 transition, and this 1 upon lambda max comes out to be 7r by 144. This is 1 by 9, this is 1 by 16, and we can simplify this. Similarly, we can find lambda minimum. For that sake, it has to come from infinite to third level, so it's basically r by 9, and using these numbers we can find the range. So Paschen series range of wavelength is from 9 by r to 144 divided by 7r. For Balmer series we have these extreme wavelengths, so range can also be stated there. So that range is going to be 4 by r to 36 upon 5r. Now you see this range. This starts, well, capital R is everywhere, so it starts from 9, or we can say from 9 by r, and goes up to this. Whereas Balmer series is start from 4 by r to 36 by 5r. Now if you look at 36 by 5r, then you'll find it's going to be 7 point something divided by r. That means it's less than 8 by r. So it is inside 8 by r, and this is beyond 9 by r. So wavelengths that we are going to get in these two series, that is in Balmer and Paschen, they will not be overlapping. So wavelengths are not overlapping if we consider their ranges. So statement B is wrong because it says they overlap. Then for C and D together, they both are talking about the Lyman series. So if we talk about the Lyman series, this is 1 upon wavelength. Again, you can find the max and min. So lambda max is going to be from 2 to 1. So, and lambda min is going to be from infinity to 1. So its range, Lyman series range is going to be from 1 upon r to 4 by 3r. That means 1 upon r to 1.33r. And if you look this option D, which says wavelength of Lyman series and Balmer series do not overlap. So you see Lyman series runs from 1 upon R to 1.33 R, whereas the Balmer series goes from 4 by R onwards. Hence they are not overlapping. Hence we can say option D is correct. Then for option C, which says in the Lyman series, wavelengths can be given by this expression where lambda naught is the minimum value or shortest wavelength. So consider the shortest case. So shortest wavelength is 1 upon R, and as per the formula 1 by lambda is equal to R 1 upon 1 square minus 1 upon n square. Now R can be replaced as 1 upon lambda naught because lambda naught is shortest wavelength. So this will be like this. From here we can make it upside down, so lambda is equal to lambda naught, and it's going to be like n square divided by n square minus 1. We can write like minus 1 plus 1, so that can be simplified as 1 plus 1 upon n square minus 1. Now n is an integer, of course, so it's coming like 1 plus 1 upon integer square minus 1 into lambda naught, whereas this says 1 upon 1 plus 1 upon m square. So this and this, they are not matching. That is basically m square is going to be equal to n square minus 1, and integer square minus 1 is not going to be square of another integer. So we can say the option C, whatever it's saying, is not correct. Hence final answer will be option A and option D. So A and D are the correct responses. Thank you.